Hi students, in this class we are going to study the ABCD constants of nominal T network of transmission lines. This is a two-port network. This is the sending end port. This is the receiving end port. We can write the sending end voltage and the sending end current in terms of receiving end voltage and the receiving end current. ABCD are the constants. We can find out ABCD for any type of network. Here you can remember we are writing the voltage equation first. Here also we write the receiving end voltage first, then the receiving end current. So this is how we write the voltage and the current equation using ABCD constants. Now we'll see how we can write ABCD constants for nominal T network of transmission line. In the nominal T network, as you know, the capacitor is concentrated at the middle of the transmission line, and impedance is equally divided on both sides of the transmission line. Here it is Z by 2, here also it is Z by 2. Now we have to write Vs and Is. Let me write the sending end current equation first. Is equals, a part of Is flows as IR and a part of Is flows as IC. So we can write Is equals IR plus IC. This is equal to IR plus IC is the current flowing through this capacitor. It is voltage into admittance. Admittance is 1 by reactance. This is equal to IR plus, as you know, V1 equals the receiving end voltage plus the drop across this part of the line. That is VR plus the drop in this part is IR into Z by 2 into Y. So this is equal to IR plus VR into Y plus IR into YZ by 2. So the sending end current Is equals VR into Y plus IR into, where the coefficient is 1 plus where the coefficient is YZ by 2. So we can write the sending end current as VR into Y plus IR into 1 plus YZ by 2. Now we got the equation for Is. We have to find out a similar equation for the sending end voltage. Vs equals the total sending end voltage equals the receiving end voltage plus the drop in this part of the line plus the drop in this part of the line. That is VR plus the drop in this part is IR into Z by 2 plus the drop in this part is Is into Z by 2. So this is equal to VR plus IR into Z by 2 plus Is equals this much. It is VR into Y plus IR into 1 plus YZ by 2 into Z by 2. So this is equal to VR plus IR into Z by 2 plus VR into YZ by 2 plus IR into Z by 2 plus IR into Y Z square by 4. So Vs equals VR into, here the coefficient is 1 plus, here the coefficient is YZ by 2 plus IR into, here it is Z by 2, here the coefficient is Z by 2. Z by 2 plus Z by 2 is Z plus, here the coefficient is Y Z square by 4. So this is our sending in voltage equation in terms of VR and IR. So now we got the sending in voltage equation and sending in current equation. The coefficient of VR in the first equation is the constant A. The coefficient of IR is B. When it comes to the second equation, the coefficient of VR is C. The coefficient of IR is D. So in general, we can write Vs is equal to A into VR plus B into IR. Is equals C into VR plus D into IR. For any network, usually this A equals D and AD minus BC is equal to 1.